Algebra 2 Honors 6.4 notes. So these are a little bit more lengthy, but follow the instructions that I'm giving you because I expect this on your homework. And it's all about transformation of graphs. And so these are going to be no calculator for the most part to get started here. And there will be some that I allow a calculator on, but we'll try to differentiate on which ones those are. So anyways, we're going to be able to, we want you to transform both exponential and logarithmic functions using our transformation. So once again, here's this table about our different horizontal, vertical reflections, and horizontal and vertical stretches and shrinks. And so in example 1 here, you're going to be graphing a transformation of 1/3 to the x. And when you see this 1/3 to the x for f of x, and then g has this -5, that is of this form. And since it's negative, you're going to be going down 5 units. G is a shift down 5 units of f. So G is a shift down 5 units of f. And then I expect that you can do a table of values for 1/3. We saw that the other day. So if you start with f of x and use -2, -1, 0, 1, and 2, and I want to see where these points specifically go in the transformation. And if I start at the bottom, 1/3 squared is a 1/9. 1/3 to the first is 1/3. 1/3 to the 0th is 1. And then if it's to the -1, I flip the fraction and make the exponent positive. So this is 3, and 1/3 to the -2nd is 9. You should be able to do that without a calculator. And so then when I do the function g, if it goes down, I need to just subtract 5 from y, from all the y values. So my x values are not going to change. And then the 9 subtract 5 is 4. The 3 subtract 5 is -2. 1 subtract 5 is -4. And 1/3 minus 5 is a -4 and 2/3. And 1/3 minus 1/9. I didn't do that right. Sorry. 1/9 minus 5 is a -4 and 8/9. Remember, this function in general, since the base is between 0 and 1, is a decreasing function. And the domain on this is all reals. And the range is 0 to infinity. But when you look at the function g, you have shifted it down 5. And so g is going to look more like this. And so its domain is still all reals, but its range, sorry, forgot to label that. The range on it is going to be from -5 to positive infinity because it's dropped down. And it said graph each function, so we're going to come here and graph the 1/3 at -2. We're up at 9. -1, we're at 3. At 0, we're at 1. And then we're at 1/3 and 1/9. And so I'm going to dot the parent function here. And remember, we want it to run parallel to its horizontal asymptote. It has a horizontal asymptote of the x-axis, which is y equals 0. And then when I graph, so we can label this, by the way, f. And then I'm going to drop in 1, 2, 3, 4, 5. I'm going to now have a horizontal asymptote for g at y equals -5. And then -2, I am at 4. And maybe I'll just do this in a different color. And at -1, I'm at -2. 0, I'm at -4. I'm at -4 2/3 and then 1/9. And so G is going to look like this. So you need to have points that plotted accurately. You need to be able to identify domain, range, asymptotes, and give tables of values showing where these points end up under the transformation. Let's look at another one. Now, this next one is going to involve some memorizing. I want you, our parent function here is y equals e to the x, and then we're transforming it. And g is, since we have an x plus 2, that's left 2, and a -1, it's down 1. So g is a shift left 2 and down 1 of the function f. Oh, by the way, on the last one, I should have labeled that this is g. All right, so I want you to memorize a table of values for e to the x, 5 points to just the nearest tenth. And I want you to memorize them for these 5 x values. And for -2, e to the -2nd is 0.1. To the -1st, it's 0.4. At 0, it's 1. And then e is about 2.7 something. So to the first is 2.7. And squared is 7.4 to the nearest tenth. I want you to memorize those 5 points. And e to the x is approximately that 2.7 to the x, meaning its base is greater than 1. And so it's an increasing function. Basically looks like that going through the 0.01 for the y-intercept. And so we can go ahead and plot it. -2, we're at 0.1. At -1, we're at 0.4. At 0, we're at 1. At 1, we're at 2.7. And at 2, we are at 7.4. And it needs to, this is going to be the parent function, e to the x, so I'm going to dot it. And it needs to run parallel to the x-axis, so this is the y equals e to the x, or label it with f. Now we're going to shift this left 2 and down 1. So I want the table of values where these 5 points go. So left 2 affects x, so subtract 2 from x. And those will be my 5x values that I need. And then down 1, subtract 1 from y. So 0.1 minus 1 is a -0.9. 0.4 minus 1 is a -0.6. 1 minus 1 is 0. 2.7 minus 1 is 1.7. And 7.4 minus 1 is 6.4. So we have just subtracted 1 from all the y values. And since it's gone down 1, what happens is instead of the x-axis being a horizontal asymptote, that gets shifted down 1. And the horizontal asymptote is going to be y equals -1 instead of y equals 0, versus on the original, the horizontal asymptote was y equals 0. I'm going to change colors. So if I go to plot this, at -4, I'm at 0.9, -0.9. At -3, I'm at -0.6. At -2, I'm at 0. At -1, I'm at 1.7. And at 0, I'm at 6.4. and then have it run parallel to that horizontal asymptote and go through those points. And there is my function g. And then you should be able to give me on all of these domain and range. Well, e to the x is exponential function. Domain's negative infinity to infinity. And the range of this was 0 to infinity. Since I've gone left, the left on the function g didn't affect my domain. But going down one definitely affected my range. It's from -1 to infinity instead of from 0 to infinity. All right, example 3. This one has a little bit of it's a little bit tricky. We have y is equal to 2 to the x. And so I'm going to go ahead and just start with a table of values for x and 2 to the x using -2, -1, 0, 1, and 2. That's our parent function f. And if it's 2, 2 squared is 4. To the first, it's 2. 2 to the 0th is 1. 2 to the -1 is a 1/2. And 2 to the -2 is 1/4. So those are just points you should be able to quickly list out for 2 to the x. And they want you to graph each function, so I could go ahead. It's 2 to the x, the base is positive, so I expect overall it's going to be an increasing function. And so we've got -2, we're at 1/4. And at -1, we're at 1/2, and at 0, we're at 1, and at 1, we're at 2, and at 2, we are at 4. And so I'm just going to dot that. And there is the basic parent function 2 to the x. Now, we haven't really seen this combination of 2 times x has something to do with a horizontal shrink and then the -4, but there's an order, and it's not left to right in this case. In this case, you ignore the 2x, and you need to perform the going right for first. So you just have to memorize this. So G is a shift right. That has to be done first. 4, followed by, indicating there is an order, followed by, and when you have that 2 times the x, you have to flip it, and it's a horizontal shrink of 1/2, followed by a horizontal shrink of 1/2. And so the right 4 is going to add 4 to the x's, but then the horizontal shrink also affects x, so I'm going to do this in 2 charts. So I'm going to do right 4 first, because they both affect x. I'm going to do it in 2 charts. So that way, if I just go to the right 4, I'm going to add 4 to each of my x values in this table. If I add 4, I'm at 2, then 3, 4, 5, and then 6. And then my y values stay the same. And then followed by the horizontal shrink. So we're going to do all of it next. So we're going to have x, and then we have this 2 to the 2x minus 4. The y values are not changing. Y is not affected by these, just the x's. And order is important. And so horizontal shrink of 1/2, you have to multiply the x values by 1/2. So 2 times 1/2 is 1. Then we have a 3/2 or 1.5. Half of 4 is 2. Half of 5 is 2.5 or 5/2. And half of 6 is 3. So those are my final points, and that is the chart that you need to end up with. And so I'm going to go ahead and graph that. So at 1, I'm at 1/4. At 1, oops, I just put that at -1. I can get rid of that. Oh well. To go back and just kind of draw that in. All right. Can't believe I did that. Okay, so at 1, we're at 1/4. At 1.5, we're at 1/2. At 2, we are at 1. 2.5, we are at 2. And at 3, we are up at 4. So here is my function g, and here is my parent function f. So both of them have a horizontal asymptote of the x-axis, y equals 0, and both their domains are infinity, negative infinity to infinity, and their ranges are 0 to infinity. All right, let's look at 3b. On 3b. And here we have this e to the negative x. And so remember e to the x, those 5 values I want you memorizing. Negative 2 is 0.1, negative 1 is 0.4, then we have a 1, a 2.7, and a 7.4. And then the negative x is a reflection in the y-axis. And when you reflect in the y-axis, you multiply the x's by negative 1. So we're going to have a positive 2, positive 1, 0, negative 1, negative 2 for these y values. See, notice I'm not picking up a calculator, I'm not looking at Desmos, and I can just go through these and figure out ordered pairs that are on my final graph. And then lastly, I have this negative 1/5, and that's outside the function. That is a reflection in the y-axis and a vertical shrink of 1/5. So G is a reflection in the y-axis followed by a vertical shrink of 1/5. And so to get that done, you are just going to end up multiply all the y values by negative 1/5. You can do those both in the same step. So all the y values are going to be times a negative 1/5. And a negative 1/5 is the same as a negative 2/10, which is the same as a negative 0.2. So you're going to be multiplying by negative 0.2. So my graph here all right, so the graph of this, I need to take this chart of values and just multiply the y's by negative 0.2. So my x's are going to stay. And then multiply the y's by negative 0.2. You have 2 decimals, negative 0.2. 2 times 0.1 is negative 0.02. And then we get a negative 0.08 if I multiply by negative 0.2. 1 times a negative 0.2 is negative 0.2. And if I double 27, I have 54. But it's negative in 2 decimal places, so we have a negative 0.54. And 7.4 doubled is 14.8. And move the decimal to the left one. And so we have a negative 1.48. And so in this case, we have to be a little bit careful because the e to the x wasn't my f function. It says graph each function. We need to graph f equals e to the negative x, which is this chart. So at 2, I'm at 0.1. At 1, I'm at 0.4. At 0, I'm at 1. At -1, I'm at 2.7. At -2, I'm at 7.4. So this was my e to the negative x. I expect that because it reflected over the y-axis, and so it ends up being a decreasing function. Then the next one, g, is taking this function, e to the negative x, and flipping it over the, oh, I wrote reflection in the y-axis. Oh no, I meant this should have been x-axis. I'm so sorry. Yeah, the first one was a reflection in the y. G is a reflection in the x-axis followed by a vertical shrink, a 1/5 of f. Sorry about that. And that's why you can multiply y by -1/5. And so as we go to graph this, at 2 we're at -0.02, and at 1 we're at -0.08. We can't graph that accurately, so we're going to be a little off the x-axis more than what we'd want. And then we're at -0.2. At -1 we're at -0.54. At -2 we're about 1.5. So we're just going to draw it like this and have it run parallel to that x-axis, and that is my g function. And the other one was f. Okay, so there's some graphs of exponential. So this will take you a little bit of time. And so that's why I'm getting the video done, so you can have extra days to get started and work on it. All right, so logarithmic functions have the same kind of transformations. And so just to show you kind of what they look like, since these are kind of new, and there they are in the chart. So describe the transformation of this, which is your common logarithm of base 10. There's an understood base 10 in there. And then we've got this transformation. And so when I see that inside there, it's a combination of negating x, which is a reflection in the y-axis, which causes you to multiply your x values by -1. But then we also have it times 1/4, which is this kind of thing, which is a horizontal stretch. It's a stretch, and it's a factor of 3. This is going to be a horizontal stretch by a factor of 4. So G is a reflection in the y-axis. And a horizontal stretch by 4. You have to flip the 1/4. It's by 4 of f. So the reflection in the y-axis, you multiply x by -1. A horizontal stretch, you multiply x by 4. So all of these combined together, we're just going to multiply x by -4 because they're both multiplying x, so we can do it all in one shot. But we need to get values on this log function. And so what I am going to do is I am first going to look at the base of 10 and get points on the exponential, which is its inverse, because I think it's easier to think about points on that. I use -2, -1, 0, 1, and 2 for x and 10 to the x. Then I'm starting at the bottom. 10 squared is 100. 10 to the first is 10. 10 to the 0th is 1. 10 to the -1 is 1/10. 10 to the -2nd is 1 over 10 squared, or 1/100. And why I did that is because then on the function log base 10 of x, since it's an inverse function, these points just switch. So 1/100th will be -2, 1/10th will be -1, 1 will be 0, 10 will be 1, and 100 will be 2. What's happening is I've got log base 10 of 1/100th is the same as log base 10 of 10 to the -2nd. And when these match, then the answer is just that exponent. But I can just take these points on 10 to the x and switch them and get points on log base 10 of x, which I like to do it that way. All right, and so now I've got my parent function. So I had to do I did the exponential in order to get points on the parent function, y equals log base 10 of x. Now I'm ready to multiply x by -1/4 to get the points on my final graph of g. So multiply all the x values here by -4. So I'm going to have a -4/100ths, a -4/10ths, a -4, a -40, and a -400. And for those, the y values stay the same. So graph log base 10 of x. So start by graphing this right here. At 1/100th, I'm at -2. At 1/10th, I'm at -1. At 1, I'm at 0. And notice I've got 8 and 16. So 1 is actually right here. I went by 2's on the x-axis. And then at 10, I'm at 1. And then I'm going to be way out to 100. So here is my graph of f. Domain, 0 to infinity. Range, -infinity to infinity. Horizontal asymptote of the y-axis, x equals 0. But now I am going to have a horizontal stretch by 4. So we're pulling away from the y-axis. And we also had a reflection. So it's flipping over the y-axis. So at a -4/100ths, I'm at -2. At a -4/10ths, I'm at -1. And at -4, I am at 0. Because it got flipped and stretched away from the y-axis. And then way at -40, I would be up at 1. So as I go to graph this, I'm going to show it going parallel there. Oops. And then I'm going to show that it's got to get all the way to 40 before it hits 1. So I'm going to show it goes off the graph before it hits a level of 1. And there's my function g. And here's f. And so, yeah, on this function, the domain on this one is -infinity to 0. By the way, on the test, I had people writing it this way. No, you put the smallest number on the left when you do interval notation. So you can't get, I'm not going to be giving credit for that anymore. You've got to put the smallest number on the left. And then the range on this, it goes -infinity to infinity. And for your asymptote, you have a vertical asymptote, and it is the y-axis of x equals 0. All right, so one more graph, and then we have a couple of transformation problems that will also be in your homework, but let's look at this. And so I'm transforming the log function of base 1/3. So I'm immediately going to think, okay, if I have the exponential of that same base, and I think of these 5x values, what are they? And we already did this earlier. 1/3 squared is 1/9. 1/3 to the first is 1/3. 1/3 to the 0th is 1. To the -1 will be 3, and to the -2 will be 9. Those are points you should be able to understand, no calculator, and should be fast and easy for you. And why I did this is because then on this y equals log base 1/3 of x, I just switch. These are inverse functions. 1/3 to the x and log base 1/3, these are inverse functions. And so I just switch these points. So if I go to graph this, I'm at 9, -2. I'm at 3, -1. I'm at 1, 0. I'm at 1/3, 1. And at 1/9, I'm at 2. So this parent function, because its base is between 0 and 1, goes like this. Now, the transformation is this 3 is going to be a vertical stretch by 3, and then this is going to make it go right 2. So G is a vertical stretch by 3. And shift right 2. And then the nice thing about this is that the vertical stretch by 3 means we multiply y by 3, and the shift right 2 means we add 2 to x. And so we can do this in one graph because one thing affects y, one thing affects x. And so we can write the table of values of this without having to do two tables. So for G, I need to add 2 to the x. So 9 plus 2 is 11, 3 plus 2 is 5, 1 plus 2 is 3, and then we have 3 and 1/3 and 3 and, oh, whoops, I added the wrong amount to that. Let me try again. Adding 2 to x. So I was doing okay. 2, we were going to have 2 and 1/3. That doesn't look like 2 and 1/3. And then we're going to have 2 and 1/9. And then we have the vertical stretch by 3, so we're going to multiply all the y's by 3. So here are all the y's. -2 times 3 is -6. -3, 0, 3, and 6. And so that graph of G, at 11, I would be at -6. Should be out here. And then at 5, I'm at -3. At 3, I'm at 0. And at 2 and 1/3, I'm at 3. And at 2 and 1/9, I'm up at 6. Because what's just happened is I have a new, since we shifted to the right, my vertical asymptote has shifted to the right. So it is going to curve, and it's going to continue forever. Put the arrows. So there is your G, and here was your F. And so on this final function G, you have a domain of 2 to infinity. You have a range still a -infinity to infinity. And you have a vertical asymptote now at x equals 2 because of the shift to the right. Okay, and then lastly, we've seen these from pretty much the beginning of the year. Let the graph of G be a reflection in the x-axis. And that means we're going to be taking the opposite of f of x, and then a translation 2 units left. So we need to go 2 units left, and so that's going to be replacing x's with x plus 2 of the graph f of x equals 3 of x. So g of x, I have to negate it, so I have a f of x is the opposite, and then where I see x, I need to replace it with x plus 2, and that is g of x. Example 6, let the graph of g be a translation 1 unit down. So that's going to mean I need to take whatever f of x is and subtract 1 from all of it, followed by a vertical stretch. And it says followed by a 5. And that means I need to take 5 times this entire function after I have shifted it down 1. So I'm going to have to distribute the 5 across f of x and the minus 1. So I'm going to do this in 2 functions. So I'm going to just say, first of all, it's m of x by shifting this down 1. And so make sure that you have that outside so it's clear that it's to the right of f of x. And then g of x we have to multiply by 5. So it's 5 times this. And you have to distribute that. And you need to do the distributing. Don't leave it like that. And so you have to make sure you distribute and multiply the minus 1 times 5 as well. That's it.